For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below. In the last video, I showed you how to add, subtract, and scale two vectors. We had our vector u, which was just this, and we also had our vector v, which was this, and then we added these two vectors and we got vector u plus vector v. That's what this, to be specific, this was 3 plus 3, that's 6, 4 plus 1, that's 5. That is what this vector in purple is. Now here's a way to think of this vector. This vector is a combination of these two vectors. To get to this vector, we simply just added vector u and v bare bone. But we can also scale the vectors and add them together as well. So let's try that. So 2 times vector u plus vector v. That would be 2 times vector u is 3, 4. When you have this, you multiply it to each entry, so that would be 6 and then 8, and then plus vector v, which is 3, 1, so 6 plus 3, that's 9, 8 plus 1, that's 9. So then this vector here is 9 to the right and then 9 up. So this is 2 times vector u plus vector v. And this is also a combination of these two vectors with this scalar. Remember that anytime we multiply a vector by a number, we call that number a scalar or a weight. Same thing. And we denote it as c. So in this case, c is equal to 1 because it's just 1 times vector v. In this case, c is equal to 2. Scalar is 2. Scaling u, vector u, by 2. So we have 2 times vector u plus whatever vector v is. So the idea is that both of the vectors are combinations of these two vectors and their scalars. For this one, the scalars were 2 and 1. Here we scaled u by 2. We did 2 times u. Here we didn't scale. It's really just the same thing as 1. But that's the idea. And if you keep doing this, if you keep scaling like 4 times u and 2 times v and adding them together, that's another combination. That's going to give you another vector, and you can say that that vector is a combination of the vectors and scalars. Moreover, we can say it's a linear combination because this is a linear equation. And as I said, there's a billion possible combinations. You can put any number here, add these two together, and you will get another answer. And so that would be another vector, and maybe another vector. And so all of these vectors are linear combinations of these two vectors right here and their scalars, whatever they may be. And so a question that we can ask is, given one of these vectors, can you tell me if that vector is a linear combination of these two vectors and their scalars? And that is a question that we can answer.